Hey everyone, thanks for tuning in. In this episode, we're once again having a look at the Retro Console Digitizer, or RCD, that I'm building from scratch to convert the analog video output of our favorite retro gaming consoles to a digital format suitable for modern HD TVs. After about 3 months of development, I've made quite a bit of progress that I'd like to share, so let's have a look. The main upgrade this time around was the implementation of a full frame buffer using this 2GB RAM module present on the FPGA evaluation board. All incoming video information is stored in RAM before being displayed on the digital output. Using a frame buffer helps a lot during temporary loss of synchronization between input and output frame rate, as it always stores enough information to display a full frame. For the sake of demonstration, I'm intentionally disabling synchronization for an extended period of time to show the different video output with and without frame buffer. It can be seen that when using a frame buffer, even a prolonged loss of synchronization only causes minor screen tearing. Being able to store a number of past frames in RAM also enables the implementation of better deinterlacing techniques than simple bobbing. The first improvement is the so-called weave deinterlacing, which combines the current field with the previously acquired one. With this method, static elements on screen appear very well defined, while moving elements have a sort of combing effect. Oversimplifying the situation, one could say that bobbing is better at representing moving elements, while weaving is better at representing static objects. The solution to this problem is to implement motion adaptive deinterlacing, where the current field plus 3 previous fields are utilized to detect the areas of the screen that are moving. In those areas, bobbing will be used, while the static portions of the frame are deinterlaced with weaving, resulting in a vastly better image quality compared to any of the two techniques used alone. And finally, selectable antialiasing was implemented, which can be helpful for smoothing out some jagged edges in early 3D games. However, I personally like to keep it disabled in pixel art titles in order to best appreciate the art, but that is a matter of subjective taste. Once again, these algorithms are designed not to introduce additional latency, so that the total input to output delay remains well below 1 millisecond. Now let's have a look at some gameplay captured directly from the Elgato H60. Video format information and settings for anti-aliasing and deinterlacing are displayed on screen. As for the next steps, there are still a few things left to do. First of all, analog audio still needs to be digitized and transmitted to the TV alongside the digital video. Some picture adjustment capabilities like overscan and horizontal and vertical alignment would also be a nice addition. Other than that, I'm currently on a spending spree trying to gather as many old consoles and games as I can, so I can make sure that all their specific quirky video formats are supported by the RCD. Anyway, I hope you liked this long overdue update on the state of the project. If you did, perhaps consider subscribing to the channel or even joining my wholesome patrons, thanks to whose support I can purchase several tools and accessories to test and develop the RCD. Thank you so much, guys. That's it for this video. Thanks again for watching, and I'll see you all next time.